Well, hello. All right, let's go ahead and get started today. Today what we're going to do is we're going to take a look at a little bit more of TCPIP programming. And rather than this being about getting a TCPIP program to talk to another program, we're going to look at kind of a subtopic of TCPIP programming called DNS. And what DNS is you may have noticed that in our programs, and part of that's cut off, so let me hide myself here for a second. In our programs that we wrote, we were using IP addresses, such as 127.0.0.1 for the local host, or, for example, the CET network that you're on, 206.24.94, 206.21.94.1, or whatever. So using these IP addresses, though, that's what actually goes into the datagrams to route them, is it has to have those addresses in there at the IP layer. TCP layer doesn't care about that. Application layer doesn't care about that, but the IP layer, the ones used for routing, that's where the addresses go. So that's put in there by the IP layer that's sent across the internet. But you'll notice that there was no place in the TCP header, in the IP header, in Ethernet that had anything to do with addresses that you're used to seeing, like google.com or reddit.com or any other URL that you're used to seeing, ssu.edu or whatever. And so the question comes up, it's like, well, if everything is based on these addresses, then how do we use names to access things? So when I go to Reddit or Discord, how do I type in that URL? How does that then work when the packets have to have addresses in them? And the idea is that the addresses themselves are kind of what underlies how the internet traffic gets routed. But for humans, it's hard to remember. It's hard to remember those addresses. It's much easier to remember reddit.com. Also, behind the scenes, a provider like google.com might change the IP address periodically for load balancing. So multiple addresses serve the same google.com depending on where you are. So rather than having people put in the addresses directly, there's a way to have you put in the name, and there's a system that looks up the name, the address that goes with that name. And that's what DNS is. So to allow users to use those names instead of the actual IP addresses, we end up using this system called DNS. And what DNS is, DNS stands for the Domain Name System, or sometimes it's referred to as a Domain Name Service. And it's essentially this underlying service that's still built using TCP/IP technology, but it's a service that allows us to look up the IP address that's associated with some name. So basically, the names themselves and the IP addresses associated with them are stored in this distributed database across a set of domain servers across the internet. So when you type a name into a browser, like www.google.com, the name is passed into the DNS system, and then the DNS system servers talk to each other and come up with, hey, who's responsible for keeping track of the address that goes with this name? That then filters its way back through the servers, back to your host machine that's making the request, and then you know what address goes with that, and that's what goes into the packet that then goes to the connection. So how does that subsystem work? It works like this. You make a function call through a DNS function call subsystem, and that function call attempts to resolve the name. And it does that by contacting whatever its defined DNS server is. If the name's defined on the, first off, if the name is defined on the local machine, the machine that's making the request, that local machine just says, oh yeah, I know the address for that, here it is. Otherwise, the function queries the defined name server for your domain or that's configured for your system. And if that server has the name, it returns that address information. If it doesn't, it asks a server upstream from it. So if that DNS server doesn't have the name, then it asks a server upstream from that. And eventually that will filter up to a top level domain. And it'll essentially make it to the machine that's defined that IP address and that name with that IP address, and then it will filter back down and give you the answer. If it can't find it, then all those servers will say, we don't know what that name goes to, and it will send you a response saying there's a DNS error, it couldn't find the name, it couldn't be resolved. And you can see that happening when you go to look up, for example, bring up a web page. When you type in the address, it'll sit there and spin for a second looking up the address, the IP address that goes with that name, and then it'll go to that site and get the data from that, unless there isn't one, and then you'll get a DNS error, meaning the DNS system could not find that particular name. Now, here's kind of a picture of how that works behind the scenes. So the client machine uses the DNS server address stored in its configuration, and your machine has a DNS server configured in that. And while we're doing that, let me bring that up and you can see where that's configured. And I'll bring that up and show you here. Here, I might have to do that later on. But let me try one more thing. Hold on. All right, well, we'll deal with that later. But anyway, if you go to your network settings, you can see what the DNS server you have configured is. And not only that, if there's a checkbox that says obtain this address automatically, you can still look up what your name server is. But if it's configured automatically, that means that when you've got your IP address dynamically from a router or access point, if you're on Wi-Fi, and you still have one configured. It's just when your computer boots up, it says, hey, I want to dynamically get an IP address, the router or access point gives it to you. And it also gives you the DNS address that goes with that. So you get an address that you can use, and it also gives you the address of your DNS server for you to talk to. So anyway, when you try to go to, for example, google.com, step one, it asks the DNS resolver, which is on kind of your machine. And if that has an answer, it would respond. If it doesn't, it talks to the root DNS server here as step two. And that will talk back and say, I don't have that, but here's somebody who do. And it kind of iterates through that and works with this DNS resolver to find the thing. Once it gets a definitive answer, google.com's DNS server, it gets this response 7, and then that gets passed back to your client 8. So that's done recursively. It starts at the top. DNS, in other words, the top level says, hey, who's responsible for .com? Okay, it's you. Who's responsible for Google? It's not you. Okay, who's responsible? So that's the top level domain server. Who's responsible for Google? Google saying, all right, this server at Google is the Google DNS server. And it says, I know the address that goes with google.com. Here it is. And here it is back to you. And then that resolver then returns that information back to you. So then you have the IP address that goes with google.com. So in code, we basically, in order to take advantage of that, we don't have to worry about how it works behind the scenes. We don't have to worry about all this stuff going on. We just need to make a single function call like this. Get host by name, google.com, and that's going to return to us this result. And that result that returns is going to be a structure that contains the address and some other information that's could be associated with that name. So let's look at the man page for that function, since we looked at the TCPIP man pages. There's a man page for this function, get host by name. Let's take a look at it. So get host by name, you can also get host by address, notice, but we're going to focus on get host by name. So notice what you pass to it is a character pointer to the name. In other words, a string, a null terminated string that is the name that we're trying to look up. And what that's going to return to us is an address of, or a pointer, a struct hostint pointer. So the address of one of these hostint structures. So the description says the get host by name function returns a structure of type hostint for the given host name. Here, name is either a host name or an IPv4 address in standard dot notation. So notice get host by name, you can also pass in the numbers and dots notation into that. Get host by address, it says that function returns a structure of type hostints. They both return the same thing, but this is given a host address addr of length n. So this version here, rather than a string, it accepts a structure that already has the address data filled into it. So that would include the normal stuff that SOC or that addr structure that we set up to make the connections. So the one we're going to focus on is get host by name. So note both functions use that struct hostent structure type as what they return. So let's take a look at that structure. So here's what that structure looks like. If you look it up in the documentation, it's got a character pointer for the official name of the host. That'd be a string that has the official name of the host. It has a character pointer. Now this double pointer is essentially an array of character pointers. So you can think of that as an array of character pointers that each one points at a potential alias name. And it turns out that, how do we know when we're at the end of that array? Well, the last one in that list is going to be a null pointer. And if you remember from your systems programming class with linked lists, how you eventually process, keep going to the next one, go to the next one, go to the next one until you get a null. That's kind of what this is. This is like a null terminated array of strings is a good way to think of that. So each character pointer points at one of these aliases. Eventually, the last one in the list of aliases, it'll point at a null. It'll have a null pointer there. And then there's this address type. There's the length of the address. And then there's this list of addresses that are associated with that. So there may be more than one address. There may be more than one name. But here's the official name, which is mostly what we care about. Is we're looking up a name. It might match one of the addresses. It might be the official name, but it'll tell us what the official name is. And it will also tell us a list of potential addresses that are associated with that name. And generally, it's the first one in this list. And this is also null terminated. But this is a little misleading. This is a character pointer, but these things that this is pointing to are not strings at this point. They are kind of 4-byte values that represent the numbers and dots notation. And we'll take a closer look at that in a second. But let's read through these. So H name, the official name of the host. H alias is an array of alternative names for the host terminated by a null pointer. The address type, in this case, it's always going to be AF_INET or AF_INET6, which is IPv4, IPv6, depending on which type. And then the length of the address in bytes. And then down here is the address list, an array of pointers to network addresses for the host in network byte order, again terminated by a null pointer. And then this HADDR is the first address in that list. And they added that HADDR for backwards compatibility because there was a time when HADDR didn't have potential list of addresses. It only could have one. And so they added that. So you could just say HADDR, it'll give you the first one in that list. Okay, the return value of get host by name. Notice that it works a lot like the other things, that the function returns that host int structure or a null pointer if an error occurs. So on error, the error variable holds the thing. So again, it'll return a null pointer if there's an error. It'll return a pointer to a host int structure that looked like this if it succeeds. And notice that if there is an error, it gives us that error in the h_error variable. And that is a global variable for host error number. And the ones that are most likely is host not found. But there might be a case where it finds the name, but it's not defined to have an IP address associated with it. There's this unrecoverable name server error. And then try again, which usually means that there was some kind of error where the DNS system was busy or being updated or something. The most common one you're going to get is host not found, where you try to look up something that doesn't exist. Okay, so here's a version of the DNS code, and notice I made this a full working program. It's got a main, it's got everything included it needs. So this would be for Unix or Linux-based system. And you'll notice I'm doing get host by name for yahoo.com. That goes into this host int structure. There's my pointer I created so that can hold the address that comes out of this. And then I just say hint hname, which, going back to that structure, remember, that's the official name. So I print out the official name here. And then I go through the list of aliases. I print all of those out. And then down here, I go through the list of addresses, and I print all those out. Now, there's something a little bit strange going on here that I need to mention. That remember that even though in that structure back here, this is listed as a character pointer, these things are really just the 4-byte or the IPv6, the larger byte addresses. And I've just made this, it works with 4-byte addresses for right now. But you'll notice here that I take what's in that slot position, I cast it as a struct in addr pointer, and then I get the thing pointed to by it, which is now the thing, and then I do this inet n to a, which is takes the internet address number and converts it to ASCII. So inet underscore n to a says take an internet address, convert it from the actual address, which it is because I just casted that into ASCII. The A stands for ASCII, and then that will show them as in the numbers and dots notation. So that's why we're doing this sequence of things here. We're saying cast that thing, which is a character pointer, as an address, get the thing pointed to by that, which gives me the actual address, and then I say convert that address into a string with the inet into a function, and then print it out using the %s print format specifier, because it is now a string that will have, for example, 206.21.94.1 or whatever the address is. And then I increment this and go to the next one, and notice I repeat that until I get to that null pointer that terminates it. Notice I do that on both of these. They're both terminated by a null pointer. So I go through all of the aliases until I get to a null, printing each one out. I go through all of the addresses until I get to a null, printing one out. But I have to do this trick where I convert it into the string using inet n to a. So that would look up yahoo.com and give me the output. Now, that get host by name and get host by address functions are considered the old way to do that. And this code actually is very similar to what would work on Windows too. I say this is a Unix, Linux version. This is very similar to how you do it on Windows, but it is a little bit different in Windows. More on that later. But anyway, the get host by name, get host by addr, or address functions are considered the old way to perform DNS lookups. And the reason that's an old way to do it is they're not quite as friendly with switching between IPv4 and IPv6. It does support that. You'll notice that it did support that. It says the type of address, it says it supports are both AF_INET and AF_INET6. So it supports both of those. But it's not really clear when you call this what this address looks like. And here I just assumed it was an IPv4 address by using that inet into a function. So there's the new way of using this is to use what's called the get addr info function and get name info functions. And those perform similarly to their old variants. So notice that here's one that deals with the address or the name for an address. Here's one that deals with gets the name info for a name. But the newer functions, they kind of make a unified way to deal with both IPv4 and IPv6 addresses. And they kind of combine the functionality of the old way of doing this into one single function call. So the newer functions make it a little bit easier to deal with both IPv4 and IPv6 addresses. And one interesting thing is those new functions, get addr info, they actually use behind the scenes get host by name, but they added an abstraction layer on top of it to make it easier. So let's look at the man page. So looking at the man page for that, get addr info. We pass in this constant character thing node. We pass in this constant character thing service. We pass in this constant struct addr info hints, and we pass in this struct of type addr info pointer res. Now looking at what those do, let's look at the description here. It says given node and service, identify an internet host and service. Get addr info returns one or more addr info structures. In other words, here's a list of those structures here. Again, null terminated. Each of which contains an internet address that can be specified in a call to bind or connect. So this is returning one of those internet addresses that we can then pass directly to bind or pass directly to connect. So the get addr info function combines the functionality provided by get host by name, get served by name functions into a single interface, but unlike the latter functions, get addr info is reentrant and allows programs to eliminate IPv4 versus IPv6 dependencies. So that's why it's considered the new way to do it. You can still do it the old way, but this is where most things are going because there are more and more servers that have IPv6 addresses. Still, the internet is mostly IPv4 or has an IPv4 interface to it. But anyway, let's look at what that get addr info, how that works. And remember, the addr info uses that addr info structure, and you can see that right here. And you pass that in for this hint, and it returns struct addr info pointer. So what those look like is this. They have flags, family, socket type, protocol, the length, the address. But they also have now, and we saw that stuff before, but they have added this canonical name field, so the name that goes with it, and they've added this structure addr info pointer AI next. And what that is, notice this is a linked list here that goes to the next one in the list. Okay, so kind of continuing down this road with the documentation for this, the man page says the hints argument points to an addr info structure that specifies criteria for selecting the socket address structures returned in the list pointed to. If hints is not null, it points to an addr info structure whose AI family, socket type, and protocol specify criteria that limit the set of socket addresses returned by that function. So in other words, we're passing into it in this hints information about the kind of thing we're trying to look up. And those things that we pass in are the family, the socket type, the protocol, flags. And it says all the other fields in the structure pointed to by hints must contain either 0 or a null pointer as appropriate. Now, continuing on, it says specifying hints as null is equivalent to setting AI socket type and AI protocol to 0, AI family to AF_unspec, AI flags to that. And the other part of this is, notice we have this node. It specifies either a numerical network address for IPv4, numbers and dots notation as supported by INET A to N. We saw that earlier. So this node thing here is what we're looking up. So that's a character pointer that could be numbers and dots. What's, for example, 146.85.1.1 or whatever. But also it says or a network host name whose network addresses are looked up and resolved. So in other words, we could pass into here in this node character pointer, we could put in www.reddit.com and it would look that up for us. Now, either node or service may, but not both, may be null. So service, we could also fill in. We're not going to worry about that. So the main use of this, the main way this is used, is to feed it in this node thing here, the thing we're trying to look up. We can fill in hints into the hint structure to say, I want this kind of connection with this type of protocol, and it will only give us results that match that. Or if I leave that null, it'll give me, say, unspecified, it'll look up anything that it has that matches that. But essentially, we're going to pass that in. So it's very similar that we're passing in a string. But notice this one function, we could also pass in an address. We could pass in a string. And it would look up the information for us either way. We don't need to use a different function to do it. Just pass in different stuff. Now, how does it return the results? The get addr info function allocates and initializes a linked list of addr info structures, one for each network address that matches node and service. And it says that's also subject to any restrictions imposed by hints. It also returns a pointer to the start of the list in results. And notice that that's what gets returned is the beginning of this list. It says the items in the linked list are linked by the AI next field. So typical linked list where you have a node that has a pointer to the next one. The last one on the list would have a null pointer to say there aren't any more after this one. And note that it says there are several reasons why the linked list may have more than one addr infrastructure, including the network host is multi-homed, accessible over multiple protocols, meaning both it supports IPv4 or IPv6, or the name service is available for multiple socket types, sock stream, sock dgram addresses. It says normally applications should try using the addresses in the order in which they are returned. In other words, if it gives you more than one, you should try using the one at the beginning of the list. That's the most important, or the primary one that was returned. Okay, so just a reminder, here's what the linked list nodes look like. So the part that we are going to care about most is this address part here, the struct sock addr. All right, so let's look at an example of this at work. All right, so here is struct addr info. There's a pointer for result. So here's another one for res. And you'll notice that what we're doing here, we're calling get addr info. I'm passing in some domain. I'm putting null in here for these two things as the hints. Address of result, that's going to be this pointer that we created up here for result. And then what I do down here is I'm going to loop through all of these, going through from one to the next. So I'm saying res equal result. Those are the same pointer type if you remember from back here. So this one's using to iterate through. This is the one that was returned as the head pointer. And I'm just going to iterate through and keep going through until I get to the null pointer at the end. And each one, I'm going to print out the information for it. But you'll notice that for the most part, IPv4 ones will show up in here. So this program, again, just like the other one, is complete, but it uses that new method of doing things. It uses the get addr info function rather than get host by name. But it's just as easy to use. You just pass the name in, and whatever the first one of these results is, that's the one that's going to have the address in it. And here what I did, I just printed out that address using inet n to a again. So this program is very similar, except it's going to return all of them. And notice I left off the code to print out if it has an AF underscore inet 6, I just have a default says, hey, that's not an IPv4 address. One important thing to do is because that function is not, or is designed to be reentrant, it dynamically allocates the memory for those results. Meaning that after you're done using those results, you need to free them. And you do that with this free addr info. You pass the pointer to that result, and it will free the allocated memory. If you don't do that, you could have a memory leak in your program where it allocates memory to store the results. If you just ignore it and let it go away, you now have that memory blocked or locked up by your process until your process dies. So always, if you call that function, make sure to free the results afterwards. Same as with a linked list. Okay, so remember to free the results using that. If you don't, you can create a memory leak. I just said that. So note that there are other possible results returned with different address families, AFINET 6, AFNet BIOS, and others. It says any program that you use that takes a domain name is performing a DNS lookup using one of those functions, either get host by name or the get addr info function. Most modern programs are probably using this one. And that's all I wanted to cover for today. I would suggest you take a close look at those programs, but just to see, if we want to see that in action, here, let's see that in action. So when I create a web browser, here, let me pull this over to where you can see it. So give me just a second here. I'll switch the camera. All right, so here's google.com. You'll notice in the address bar up there, let me see if I can make that bigger for you. Well, I guess that just makes that bigger. But up here it says google.com. When I type that in, how did I get to this page? And the answer is it looked that up for me. So I'm going to make another tab here. And I'm going to do a DNS Lookup. And I'm going to do a DNS Lookup. Here's a tool that does that. So I'm going to put in google.com. And if you look at that, it tells me the IP address associated with it. There it is there. So notice if I go up here and I put that address in directly, I get the same page that I got over here. Notice those are the same. And you'll notice that it plugged in google.com because it did that lookup and it knows what the name of that is. So again, if I plug that address in up here, there it is. It changes it to google.com. And how did it look? But really, what my program is connecting to is that IP address. That's how I'm getting this data. Again, the IP packet does not have google.com anywhere in it. The IP packets or datagrams that are traveling across the network only have the addresses. So that address is getting plugged in. Now, one interesting thing that you'll see when you run that DNS lookup program that showed all the aliases, a lot of times you'll see more than one address associated with a server. And the other interesting thing is if you were to go back and refresh those at different times, you might get a different address that comes out of that at different times. And in fact, when I clicked on that, notice it shows these domain name things here for that. And it can show other stuff about the DNS record. I guess there's not a whole lot here for this. But when you run that first example, that program we just looked at, sometimes you'll get aliases. And you'll notice that different times you run the program, the IP addresses might be in a different order. And that is one way that high traffic websites do load balancing, is that they have the DNS system say, hey, what's the name of the server for google.com? You'll give you one address. And then the next machine that asks, they give a different address. So that way they're spreading out the load across multiple actual physical IP address servers, or not physical, but physical servers on different IP addresses. So that's why sometimes you'll see those aliases like that. They're not aliases, but multiple addresses associated with that. Okay, so let's finish up today. Relatively short lecture today. That's it. Make sure you work on your program to get the TCPIP program to talk to each other. If you are having issues with that connecting, it's probably your firewall or Windows Defender or whatever creating issues. Maybe Google that and see what you need to do to allow that. But generally, you can go in and say, hey, make an exception for this particular program. I believe most versions of Windows, when you run that program, they'll pop up a box that says, this program is trying to access the internet. Do you want to allow it? And you can say yes, and then it will be fine. If it's not fine after that, then it's somewhere you probably have a firewall or something set up, but it should work. So let me know if you're having issues, and I'll try to help with that. But other than that, work on your thing. I would suggest really that you maybe try compiling and running this program and see what you get. Or maybe try compiling and running this program and see what you get. But that is essentially when you have a program like a web browser, that's what's doing those name lookups for you. All right, I'll stop there. Make sure to work on your lab, get that done, because next week we're going to have another lab coming up. So be ready for that. All right, that's it.